Chapter 1, Lesson 1, Factors and Multiples. Our content and language targets today. Content, students will understand that difference between factors and multiples and how to use them to find the greatest common factor and least common multiple. Our language target, students will demonstrate the pineapple upside down cake method to find the greatest common factor and least common multiple. So the greatest common factor, you can use common factors or prime numbers or factors to find the greatest common factor. Now, prime numbers are numbers that only have two factors, such as 2 and 4. So factors of 2, 3, 5, 7, 11. Those are the first 5 prime numbers. Okay, so when we use our pineapple upside down cake method here to find the greatest common factor, we're going to use these 5 numbers over and over and over. So example number 1 says that there are 1 slice servings of 3 types of cake at each table. Each row has an equal number of servings and only 1 type of cake. What is the greatest number of servings in each row? So we have 10, 15, and 20. So we have to find the greatest common factor, how many we can have of each one in a row. So what I would do is I would take 10, 15, and 20. And I'm going to write down all the things that I can multiply to get those. So 10, I can multiply 1 times 10 and 2 times 5. 15, it would be 1 and 15 and 3 and 5. And 20 would be 1 and 20, 2 and 10, 4 and 5. So then I go back through and I would circle all the ones that are common. Well, 1 is always a common factor. Okay, 10 has 2, but 15 does not. 10 has 5. 5 is a common factor. 10 has 10, and there's only 1 that has a common factor. So they have to have all 3. So between 1 and 5, what's the greatest number? What's the largest number? That's right. So your greatest common factor is 5. So there's that one, and we'll do that one again here in just a minute. But here's my pineapple upside down cake method. I'm looking when I do this to find the greatest common factor. The cool thing about this is that you can also use it to find the least common multiple, which we'll talk about later in this lesson. So when I use my pineapple upside down cake method, again, I want to think about the numbers 2, 3, 5, 7, and 11, because those are your first 5 prime numbers. So I look at numbers 8 and 12. I want to think to myself, what number goes into both numbers? Well, since both of those numbers are even, 8 and 12, I know 2 is a factor. So I'm going to think about what can I multiply by 2 to get 8? Well, that would be 4. And what can I multiply by 2 to get 12? That would be 6. So here I have a new layer to my cake. So again, I think about what number goes into both 4 and 6. Well, again, I think that's 2, because they're both even numbers. 2 times 2 is 4. 2 times 3 is 6. Is there any other numbers that go into both 2 and 3? No, because if you look over here, they're both prime numbers. Their only common factor is 1. So I'm finished. So how do I find the greatest common factor? Well, to find the greatest common factor, I simply have to multiply these 2 numbers together. So what is 2 times 2? That is 4. Now, if I simply write down all my factors of 8 and 12, so I look at factors, so 8 and factors of 12. Well, what can I multiply together to get 8? Well, that would be 1 times 8 1 times 8, or 2 times 4. Does 3 have go into 8 evenly? No. So I look at 12. I know 1 times whatever number that is, which is 12, are always factors. I know it's even, so 2 is a factor. 2 times 6 is 12. If 6 is a factor, that means that 3 is a factor. So 3 times 4 is 12. So now we can go back and look at all the factors that are the same. I see a 1 over here and over here. I have a 2. I have a 4 on both sides. And do I have an 8? No. So those are the 3 numbers that are the same. Those are common. So what is the greatest common factor? The largest number? My greatest common factor, again, is 4. So here we have, let's find the greatest common factor of 12 and 18. So again, I'm going to use my pineapple upside down cake method. Here's 12. Here's 18. So I want to think about numbers such as 2, 3, 5, 7, and 11 as what numbers would work to go over here. Well, 12 and 18 are both a positive number, and they're also an even number, so I know 2 is a factor. What times 2 is 12? That is 6. What times 2 is 18? That would be 9. So since I have 2 numbers there, I have a new layer to my cake. So what number goes into both 6 and 9? Well, 2 goes into 6, but does not go into 9 because 9 is an odd number. So I try 3. Does 3 go into 6? Yes. Does 3 go into 9? Yes. So I put 3 over here. What times 3 is 6? That's 2. What times 3 is 9? That is 3. Is there a number that goes into both 2 and 3? No, only 1. And so there my 4, my factoring is done. So what is the greatest common factor of 12 and 18? I take these 2 numbers and multiply those together. 2 times 3 is 6. So the same thing here. We're going to find the greatest common factor of all of these. So 12 and 66. I have 12. I have 66. Here's my pineapple upside down cake method. 2, 3, 5, 7, 11. I always want to remember those numbers. It's going to help me. Both numbers are even, so 2 is a factor. 2 times 6 is 12. 2 times 33 is 66. So again, I try to figure out another one. 2 goes into 66, but not 33 because that's an odd number. 3 goes into 6, and there's 2 3s here, so I'll bet you 3 goes into both of those. 3 times 2 is 6. 3 times 11 is 33. So both 2 and 11 are prime numbers, so the only common factor that they have is 1, so we're finished. So to find the greatest common factor, I multiply those 2 numbers, and 2 times 3 is 6. 18 and 30, same thing. 18, 30, pineapple upside down cake method. Again, both numbers are even, so 2 is a factor. 2 times 9 is 18. 2 times 15 is 30. Again, here we go. So again, I want to use my 2 is not a factor, is 3. 3 goes into 9, and 3 also goes into 15, so we'll try those. 3 times 3 is 9. 3 times 5 is 15. Again, I get 3 and 5. Those are both prime numbers, so I'm finished. So again, I multiply those 2 numbers together. 2 times 3 is 6. So go ahead and pause the video and you try the last one on your own, and we'll talk about it when you're done. So here we have 32 and 48. Same thing, they're both in even numbers, so 2 is a factor. Sometimes I use a calculator, so 32 divided by 2 is 16, and 48 divided by 2 is 24. So again, both of those numbers are even, so 2 is a factor. 2 times 8 is 16, 2 times 12 is 24. Still have numbers up here, they're both still even, so 2 is a factor. 2 times 4 is 8, 2 times 6 is 12. I still have numbers here, they're both even, so let's call it 2 again. 2 times 2 is 4, 2 times 3 is 6. And again, now I have my two prime numbers, so I'm finished. So I have to multiply these numbers together. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. And that's the greatest common factor. But now we look at the least common multiple. You can find the least common multiple by using a number line, making a list, or by using prime factors. So when I look at finding the least common multiple of 2 and 3, there's a couple ways to do this. One, I can write out all the multiples of 2 and 3 and see which one's the smallest. So the multiples of 2 are 2, 4, 6, 8, 10, 12. Multiples, I usually go by 5 or 6. Multiples of 3, I got to count by threes. 3, 6, 9, 12, 15. So then I go back and I look, which ones are the same? Well, there's no 2 and there's no 4. There is a 6. There's no 8. There's no 10. There is a 12. So then what is the least common multiple? It's the smallest number that's common. That would be 6. You can also do this using a pineapple upside down cake method. So what number goes into both 2 and 3? Well, remember your 2, 3, 5, 7, and 11. Well, these two are both prime numbers, so they only have a common factor of 1. So I would multiply these two numbers together to get 6. So my least common multiple is 6. Let's find the least common multiple of these numbers. So of 2 and 6, pineapple upside down cake method, I'm looking at 2, 3, 5, 7, and 11. I know 2 is a factor of each of those, so I take out 2. 2 times 1 is 2. 2 times 3 is 6. So here's the neat thing about finding the least common multiple here. To find the least common multiple, think of an L. I'm going to multiply all of these numbers. See how that looks like an L? So if I multiply 2 times 1 times 3, I get 2 times 1 is 2. 2 times 3 is 6. I do the same thing here for 4, 5, and 6. Yes, 4, 5, and 10, sorry. You can use more than one number or two numbers. So again, I look at these numbers and I need to find the least common multiple. I know that 2 is a factor of 2, 4, and 10. So 2 goes into 4 2 times. 2 goes into 10 5 times. So here, since 5 is already a prime number, I leave that one alone and I don't divide that. So then I'm down to all my prime numbers. So now I multiply There's my L, and I multiply each of those. So 2 times 2 is 4, 4 times 5 is 20. So again, if I look at 3, 5, and 7, I can use the other way as well. And I can look at multiples. So I have 3, 6, 9, 12, 15, 18, 21. 5 would be 5, 10, 15, 20, 25, 30. 7 would be 7, 14, 21, 28, 35, and 42. So as of right now, I don't see any that all three of them are in. 5 and 3 have 15, but not 7. So what I do notice is, though, is that all three of these are prime numbers. So they're not going to have any factors that are common unless you multiply all three of those together. So if you looked at if we looked at our pineapple upside down cake method, we would see that the only common factor that they have is 1. 1 times 3 is 3, 1 times 5 is 5, 1 times 7 is 7. So to find my least common multiple, I would have to multiply all of those together. 5 times 7 is 35, and 35 times 3 is 15, is 105.